It was good. Got a quick question for today. Today we're just going to be working on balancing redox reactions. This is going to be under basic conditions. I'll do an acid one tomorrow probably. Yeah, I guess we could just get started with it. So step one in balancing these redox reactions. I'm not fully confident. I just learned it like 2 days ago and I didn't do any practice on it yet. So this is going to be my first time. We want to we want to identify the two half reactions. So I'm assuming that this one and this one go together because they both have Cl in them, and then that one and H2, like hydrogen peroxide and O2, will go together, I assume. So we'll try that. So first reaction is Cl. This could take some time because I actually need to figure this out as I go. We'll go to ClO2 minus. So we want to assign the oxidation numbers to this. So here, O7, so oxygen will be -2. That means this is overall -14. So that means each Cl should be +7. O2, this is going to be -2. So it's going to be -4 because 2 times 2 is 4. Now we need to get to -1. That means this should be +3, right? +3 minus 4 equals negative. That adds up. So this should be our first half reaction. Now we need to balance this half reaction. Well, first we have 2 Cl's on the left, and we only have 1 on the right, so we gotta multiply this by 2. That's the first step. We need to now add electrons to balance the charge in the oxidation state. So the main focus here is going from +7 to +3. So, bro, my bad. My voice is like faded. Where do we need to add electrons? So where do we need to add negatives to get to the positive on the right side? I'm assuming that we have to add the electrons right here. 4 electrons, so that means it's +4 minus 4 equals 3. However, we got 2, so this is going to be a +6 overall, right? Because it's going to be 6. So if we're at +7, yo, now this is where I'm confused, bro. Like, we have a +7 charge here, but we need to get to a +3 here. We have 2 Cl's, each of which are 7. I assume that it would be 8 electrons. Because it'll take 4 electrons for one of them, so that means if we multiply by 2, then it's 8 electrons. I think that's right. I'm still learning this, bro. Okay, so we added the electrons. Now the next thing is to add OH minus so that the balance, like the charges are balanced. Because this is basic, this is why we'll add OH. Otherwise, I think we would add H plus and balance the hydrogens after adding something else to balance the charge. I really don't know. No, we would add H plus to balance the charge instead of OH, but we're working with basic conditions, so it's going to be OH. So what is the overall charge of this? I mean, I guess we could just delete this because it's kind of confusing. So here we have -7 here, and we have -2 here. So we need to make this, the right side, more negative. So we're missing 5, so we'll just add 5 OH minus, right? I think so. Okay, so now we need to balance out these balance out the hydrogens. Slight issue though, we have an odd number of hydrogens and water is H2O. So what do we do now? I don't know. Where do we, am I missing something? Do we have to multiply by 2? I already multiplied by 2 though, yeah? What is our charge? Yo, wouldn't this be -8? Why would this be positive? Am I dumb? This is -8. Right? Because this has a charge of 0, so -8, so this will be 8 OH. No, not H, this will be 6. -8. Yeah, so -2 minus 6 equals -8. Okay, there you go. So now we have 6 hydrogens Now we need to add H2O to balance the hydrogen, so we're gonna add sorry, my phone is buzzing. Was 6H2, so we have 6H here, so we need 3H2O. And now if we did this correctly, these oxygens should be balanced. Yes, they are. 10 oxygens and 10 oxygens. There you go. Wow, I could not figure this out before. I understand where I went wrong now. It was just I was counting the Cl2O7 as a positive charge rather than being neutral. But there you go. This is our first reaction. Now is this going to be reduction or what's the other one? Oxidation. Well, we're adding electrons, so we're gaining electrons. That means we are undergoing reduction. I know that for a fact. Now, step 2 is to balance the next half reaction and do all this again. Bro, what? H2O2 goes to O2. So O2 is going to be 0, formal charge. Oh man, I can't remember. Is O2 a negative 1 or positive 1 in this one? It's negative 1 because it's a peroxide. So this will be positive 1. So we're going from negative 1 to 0. Yep, oxygens are balanced. So now we need to balance the charges. So we have to add we have to add electrons to balance the change. So we have to add plus 1 electron. Here we are. So we got negative on the right, negative on the left. So now we have negative on the right side, so we have to add an OH minus on the left, on the right I mean. So OH minus on the left, electron on the right, so charges are balanced. Now I have to add hydrogens. Okay, now we run into a similar issue in that we have 3 hydrogens on the left side, and that's an odd number of hydrogens, bro. What do we do now? Brother, what? What do we do? What do I do? What do I do? Okay, wait, let me just think about this deeply. Does H2O2 have a charge? I don't know. Bro, this is tweaking, bro. Let me just... What do I even need to do here? I feel like I'm doing something wrong. Plus O2. Yo, I'm so lost now. Yo, the answer is they got 4 H2O2 in the final thing. Oh, probably because they had to add multiply the electrons, yeah? 2 OH there, so that means that has to be 8. That has to be 8. What? That means 2 oxygen. What is going on? Okay, here's what I'm thinking, yeah? Each oxygen is negative 1. So to go to negative 1 to a 0, we have to add plus 1 electron. However, there's 2 oxygens, so we add 2 electrons. That makes sense. So we add 2 electrons, now we're at negative 2 on this side, and now we're on 0 on the left side. So we have to add 2 OH minuses. So now we're on negative 2 on the left and negative 2 on the right. Therefore, we are balanced. So now, you might be asking, now what do we... Well, I'm just yapping. So we need to balance the hydrogens. We got 2 H's on the left, plus another 2, which is 4. 4 divided by 2 is 2, so 2 H2Os. Now, we could check if we are right by checking if the oxygens are the same. So we have 3 O's on this side, and we have 3 O's on this side. Therefore, we are balanced. Now, the final step is to make the net reaction. How do we find this net reaction? We add the 2 reactions together, but we need to make sure the electrons cancel out. So we have 8 electrons on reaction 1, which is the reduction one, and then we have 2 electrons on the right side for the oxidation one. So therefore, we need to multiply this one by 4. So that way the electrons can cancel out. I'll just write everything out again. So you have 3H2O plus Cl2O7 plus 4H2O2 plus 4 times 2, 8OH minus. This is not going to be the final answer, by the way. This is just writing it out. 6OH plus 4O2 plus 8H2O. Now we just simply need to cancel out what's common. As you can see, like when we multiply this will get 8 electrons on the right side, and we got 8 electrons on the right, so then, on the left, so therefore these two will cancel out. That's why you need to multiply by 4. So now we need to just make the net reaction. So we got 3H2O, so 5H2O, Cl2O7 plus 4H2O2 plus 2OH minus plus 2ClO2 plus 4O2. Let's check if that's right. Mink. Yeah, that's right. Wow, that was low-key kind of simple. Just kidding. I low-key was dying on that for a bit. But yeah, that's pretty much all for today. Happy I got this question done with. And I'll see you in the next video tomorrow, where we'll probably go over acidic conditions. Goodbye.